Let's do a brief review of insertion reactions in organometallic chemistry. There are two kinds of insertion reactions. There's 1,1 insertion, which mostly for historical reasons is sometimes referred to as migratory insertion. And that's the addition of a nucleophile bound to the metal to a carbon monoxide ligand or an analogous ligand. Sometimes this can be a metal hydride if the metal is from the left-hand side of the periodic table. But more commonly, you'll encounter metal alkyls, such as this methyl shown here. And when a carbon monoxide binds to the metal, I've drawn the complex with a formal negative charge on the metal, although we typically don't draw formal charges on transition metals. But for the moment, I'm doing that to remind you of this idea that the carbon monoxide has a positively charged oxygen and a negatively charged carbon, that it's transferring electron density over to the metal. And that alkyl on the metal is nucleophilic, of course, because it is more electronegative. The carbon is more electronegative than the metal. So it's easy to imagine that alkyl taking its electrons, moving over onto the carbon, and allowing oxygen to have its lone pair back again to get this acyl species here. That's a 1,1 insertion where the nucleophile has moved on to the first atom in the carbon monoxide ligand. In a 1,2 insertion, we're often dealing with a aldehyde or a ketone that's bound to the metal, but even more commonly, we're dealing with an alkene that's bound to the metal. And those look a little bit different, so we'll take a look at each of those. But in a aldehyde or ketone, we would imagine the oxygen lone pair coordinating to the metal to get a species that looks like this. And again, the metal I've drawn with a negative charge on it, although we don't normally show that to emphasize this electron transfer from the oxygen to the metal. But the oxygen is now an activated electrophile. It's got a plus charge that makes it more likely to receive electrons from a nucleophile, such as this metal hydride. And in 1,2 addition, the nucleophile is most often a hydride. And when that hydride moves over, we've got a methoxy group instead of an aldehyde. The same sort of reaction can happen with alkenes. So in an alkene, of course, I don't have lone pair donation, I have pi bond donation. So I've got pi bond donation here. And when we do that again, there's a transfer of charge, basically. And I'm just going to put this in parentheses because we wouldn't really consider this a formal charge in this case. But we're transferring some charge from the alkene onto the metal. And so although we normally think of alkenes as nucleophiles, this alkene, because it's giving electrons away, is actually going to end up acting more like an electrophile, just to keep things more analogous to what we've talked about before. So we're going to move a hydride onto that coordinated alkene. And when we do, we get an alkyl ligand. We now have an ethyl instead of an ethylene.